used to seeing feathered dinosaurs flying around and roosting in trees. But few discoveries have so completely transformed our picture of the extinct dinosaurs than the revelation that they had feathers too. Or at least some of them did. Over the past 20 years, dinosaurs of all types and sizes have been found with some sort of fluff or even full-on plumage. But these fuzzy discoveries have raised a whole batch of new questions, like exactly what kinds of dinosaurs had feathers? And how do we know for sure? And considering that the likes of T-Rex and Psittacosaurus couldn't fly, then what were their feathers even for? Well, find a perch and get comfortable, because I'm here to tell you everything we know about dinosaurs and feathers. It took us a long time to make the connection between dinosaurs and feathers and birds in general. In fact, the first fossil to give us an inkling that dinosaurs had feathers was actually one of the earliest specimens ever found. It was Archaeopteryx, discovered in 1861 from the Solnhofen limestone in Germany, which dates back to the Jurassic period. Archaeopteryx means first wing, and even in the 1800s, experts could immediately identify it as an ancient bird. After all, at the time, birds were the only animals that we knew that had feathers, and this thing definitely had them. But Archaeopteryx had some other features too, ones that were kind of strange for a bird, like a long bony tail, fingers with claws, and tiny teeth. Things that you would usually see in reptiles. Those clues suggested that birds must have sprung from the reptilian branch of the tree of life. But no one could agree on what that actually meant. It took decades of study and debate before paleontologists started to see that little Archaeopteryx looked an awful lot like a dinosaur. And it wasn't until 1996, 135 years after Archaeopteryx was first found, that a lucky break confirmed what scientists had begun to suspect. A beautifully preserved, articulated skeleton of a chicken-sized dinosaur was found in China, and along the neck, back, and tail of this little dino was a line of fuzz. Paleontologists named this revolutionary discovery Sinosauropteryx. It confirmed that at least some non-avian dinosaurs had feathers, and that the history of feathers went back way farther than anyone knew. As it turned out, Sinosauropteryx would be just the first of many finds that would show us that dinosaurs were fluffier, fuzzier, and more ornate than we had ever expected. The fossil record has turned out to be so generous. In fact, the growing menagerie of feathered dinosaurs has offered experts a pretty good outline of how feathers evolved. Dino fluff, which experts technically call proto-feathers, probably goes all the way back to the Triassic. But since dinosaurs in different times and places had a variety of proto-feather types, paleontologists are able to piece together how feathers went from basic filament structures to ones that allowed flight. For example, Eutyrannus, a tyrannosaur from China, had little wisps that grew from follicles in its skin. It also represents the largest dinosaur currently known with evidence of dinofuzz. But from those simple bits of fluff, proto-feathers became more complex over time. Dinos like the small Tyrannosaur D. long and the tiny carnivore Giravenator had proto-feathers with a central stalk that branched off near the top. And once proto-feathers started branching, they were able to take on all kinds of new shapes. The central part of the feather became a hardened structure called a rachis, with lots of barbs and barbules, creating the veins of the feather. Dinosaurs that are closely related to birds, like Microraptor and Archaeopteryx, had feathers like these. And interestingly, the closer you get to the origin of birds in the dinosaur family tree, the greater the variety of feathers you find on different parts of their bodies. So to get a sense of how common feathers were among the non-avian dinos, let's take a tour of that family tree. We'll start with this big group of two-legged Saurischian dinosaurs, the theropods. They include everything from the crested carnivore Dilophosaurus to the parrot-like omnivore Oviraptor. Zoom in and you'll find a smaller group of theropods called the Coelurosaurs. Every single lineage in this group has some kind of evidence of a feathery body covering, whether it was fuzz or full-on feathers. And this is the group that includes birds along with a whole variety of other theropods, like the Therizinosaurs with those enormous hand claws and none other than T-Rex. But that's not all. All the way over on the other side of the dinosaur family tree, there's another broader group called the Ornithischians. They're nowhere close to birds in evolutionary terms, but they have feather-like body coverings too. Take Psittacosaurus, a small horned dinosaur that used to run around China. It's been found with preserved quill-like filaments growing from its tail. Likewise, fossils of a Jurassic dinosaur from Russia called Culindrodromeus show that it was nearly covered with feather-like structures, despite the fact that it too was far are from birds. Now, the fact that feathers and feather-like structures show up in these very different groups of dinosaurs can mean one of two things. Either proto-feathers evolved more than once throughout dinosaurs' history, or they actually go all the way back to the last common ancestor of all dinosaurs, and were retained in some groups but lost in others. So we have some pretty good data about the presence of feathers within certain groups of dinosaurs, and we can use that to make informed guesses about which particular species had feathers. For dinosaurs like Microraptor, there's direct evidence of feathers right there in the rock, no question about it. But then there are dinosaurs that we don't have direct evidence of feathers for, but we think they probably had them. This is called phylogenetic bracketing, using the presence of traits across related species to make an educated guess where those traits might occur. For example, most mammal fossils aren't found with hair, but we expect that they did have hair because we know their relatives do. Same goes for the likes of T-Rex. Even though there's no direct evidence of feathers on T-Rex, there's a good chance the tyrant king was at least a little fluffy, because other tyrannosaurs have been found with proto-feathers. Ditto for Triceratops. Because its little relative Psittacosaurus had bristles, perhaps the larger horned dinosaurs did too. And then there are the dinosaurs that may or may not have had any proto-feathers at all. Will we be shocked by the discovery of an Apatosaurus or Ankylosaurus with proto-feathers someday? It's possible, but there's no direct evidence of that just yet, and no one has found any fluff on any members of those dinosaur groups. So this brings us to another question. Why? Why did dinosaurs develop feathers in the first place? Well, feathers are a great example of an exaptation. That's a trait that evolved for one reason but later became modified to do something else. For instance, remember Sinosauropteryx? It lived on the ground and couldn't fly, but its simple coat of fluff still had advantages. For one thing, feathers are great for insulation. Think of that the next time you put on a down jacket. And they're also really handy for display. The tail of Sinosauropteryx was banded rust red and white, which probably helped it signal to other members of its species. And other dinosaur displays were even more ornate. The fossil remains of a small, strange dinosaur called Epidixipteryx show that it had long, ribbon-like tail feathers, structures that may have been well suited for doing the dinosaur version of a fan dance. But even as proto-feathers started to get more complex and came to look more like the structures on the wings of birds, they still had plenty of uses for life on the ground. For example, an amazing skeleton of the dinosaur city Peabody was found in Mongolia with its arms in a brooding position over a nest. Based on what we know about its relatives, this dinosaur must have been feathered and may have used its feathered covered arms to protect its nest. Feathered arms are also good for more active pursuits. Studies of living birds like the chukar partridges have shown that birds can get a better grip on inclined surfaces like tree trunks and rocks when they flap their wings as they run. Smaller feathered theropods with long feathers on their arms may have used this technique, possibly to evade larger non-climbing predators. And finally, feathers might have made some dinosaurs even better hunters. Ground-dwelling dinosaurs with long arm feathers like Deinonychus probably weren't eviscerating their prey with those terrible foot claws. Instead, they may have acted like modern-day raptors, pinning down small prey and flapping their wings to help stabilize their grip. So feathers had all sorts of uses. That's what made them the ultimate dinosaur accessory. And it's what allowed some dinosaurs to eventually take to the air. What evolved on the ground opened ways for the terrible lizards to take flight, a tradition they have mostly kept to this day. But our knowledge of the when, why, and how of dinosaur feathers is still pretty new. Remember, it took nearly a century after the discovery of Archaeopteryx for paleontologists to finally see the relationship between birds and dinosaurs. And it took another 3 decades before fossils like Sinosauropteryx started changing our view of how feathery some dinosaurs really were. Each new find will continue to enhance our vision of the non-avian dinosaurs. But for now, the next time you see a winged dinosaur flying around, feasting at your bird feeder, or standing on the head of some statue, take a moment to appreciate the hundreds of millions of years of evolution that made that sight possible. Thanks for joining me on this extra feathery episode of PBS Eons. Now, what do you want to know about the story of life on Earth? Let us know in the comments, and don't forget to go to youtube.com/eons and subscribe. And you're not done exploring yet, are you? Check out some of our sister channels from PBS Digital Studios. If you're interested in great beginnings like we are, then check out the new channel Origin of Everything, which explores history of objects and ideas from everyday life, from where the hashtag came from to why 18-year-olds are considered adults.